Okay, so for those following along with me, the B's are what's getting put into my EIP. So that's what my stack frame. That's what should be the address of virtual protect. So I'm going to virtual protect from here. Okay. This should be my return address, and the return address should be the address of my buffer, which is 13FB6C. That's assuming that I put my shellcode right at the beginning of the payload. So that's just what I'm going to do. That's what I'm going to do. Okay. Next is just -1 in hexadecimal. Okay. Here's what I'm going to do. I'm just going to change the permissions on the very last page of stack memory where my stuff is. So I'm going to make this 00 at 0 1300. And I'll make, let's see what comes next. The size, this should be 10. Oops, it's got to be backwards. It's got to be in a little Indian. Remember that? 0010 00. So it's my size field. New protect needs to be 40. Little Indian again, remember? And an old protect. This value kind of gets some people. This needs to be any writable data area. So let's see. I'm going to make mine 13FF00. That just points right before my fake stack frame and out of the way of my shellcode. And that should be good. But now I'll actively try to debug this as I run it, so I can just sort of go through the process and show you what you should see and what I would do if something wasn't right. So I already have a breakpoint set on my stack pivot that add ESP868. And if you don't have one, you should have that as well. We want to start stepping as soon as we really gain control of the EIP. It looks like I messed up some of my addresses here. Is that right? 10086068. 10086068. It's like when you debug is having a hard time or something. So 20. All right. Occasionally, WinDebug gets crazy. Time to restart WinDebug. And let's start debugging even further back, right where the overflow occurs. Okay, so my buffer is at 13FP6T. Exception handler, where's that at? 13FFP0. So an offset 444 into the file. I should be overwriting that stuff. 6A 60 0810. Let me make sure that looks right. Okay, that looks good. So I set a breakpoint on the stack pivot. Now I want to start single stepping and see what happens. Make sure my parameters to virtual protect look correct. So I'll do T. See what the stack looks like. It should be pointing to my fake stack frame now. So 7C801A61. Yeah, so that's virtual protect X. That's good. 13FP6C. That should be the address of my shell code, which I haven't put anything there yet, unfortunately. I'll hack in a CC byte for now. Just kind of like hack in some 4-byte test shell code for myself to see if this works. That's all good. Okay, this is -1. That looks right. 13F000. That should be good. 1000. That should work. 40. That should be page execute read write. So making everything executable. 13FF00. Just make sure that's out of the way of everything important, because it's going to write some data there, the old protect values. Okay, so that looks good. All right, so now I'm in virtual protect X. You can also look at the parameters here. All looks good. And here's an important step that you guys should try if it's not working correctly. And it's the step out function. And this will continue execution until the function is done. That will allow us to inspect the return code of the virtual protect function to see if it succeeded or not. So it'll step out. Let's see if we got lucky. 1. 1 is good. That means virtual protect looks like it succeeded. So if I do like a T, should hit like software breakpoint. That's good. We're happy with that. So theoretically, I could just copy and paste my shell code at the beginning here, and it would magically work. Sort of think that something bad's going to happen to me. I can just feel it coming, but we'll try it anyway. Now, here's another important part where you can kind of screw yourself up. If you do a Control-V in HXD, it'll change the size of the file and shift everything around on you. That's bad. You want to just overwrite these bytes so the total size stays the same and it doesn't shift your stack frame down and that fake exception handler down in the payload as well. So I'll go to paste write. That's a Control-B. Don't increase the size of the file. Save it. Do a dot restart. Say a prayer to Papa Legba. Hey. Are there any steps in that process I just went through that would be helpful for you guys for me to go through again? Or would you like me to just try to answer individual issues that are coming up? Did that help clarify at all the debugging process, Jessica? So what could have happened, I'll just show you guys, is I'm going to mess up the parameters to my stack frame a little bit. I'll make this too big. And I'll walk through the process again. So that breakpoint is not still set, unfortunately. Dang it. All right, so that's my stack pivot. I want to break on my stack pivot and start single stepping. Something isn't working right. What's going on? Okay. P, PDESP. Okay, all my parameters look correct. I'm pretty happy about that. I'm in virtual protect. Let's step out and see what happens. Uh-oh. Virtual protect failed because EAX is 0. One possible reason why it could have failed is that if you try to protect too much memory, virtual protect will fail because it will say that, hey, you're trying to protect memory that isn't even mapped right now. Because 13F00 plus A000 is going to end up pointing to like unmapped memory. We can even test that out. So you can see it's like not mapped in. So if you try to force in virtual protect and change permissions on memory that isn't there, it's just going to fail. It's not going to do anything for you. So the parameters that work for me that I usually use is just kind of like the minimal amount that I need to change that's possible. So in my case, I used 13F000 and 1000. That should really work for everyone, I think. And another way you can kind of mess yourself up is this last parameter, the old protect values. If you make it somewhere important, like in the middle of your shellcode, it's going to override bytes from your shellcode. That's bad. If you make it in the middle of your stack frame or near your stack frame, you can potentially clobber your big stack frame and cause issues. And if you make an address that isn't writable or is bogus, virtual protect will fail again. So what I did is I tried to just make it like right before my big stack frame, basically. And that seemed to work good. Those of you that have already gotten it, you should be working on the return-oriented programming stuff.
So for the ROP stuff, when you're trying to compute the address to pass the virtual protect, you've got the stack pointer, but you kind of need to mask that down to something a little lower.
Lower or higher?
Well, I'm assuming that ESP is pointing somewhere in the middle of the stack, so I need to adjust the address to a lower address.
Why is that?
Because I want to make sure that I change the protection on. I mean, I guess I could start at ESP, but I don't remember, was my payload later than ESP? And as you just pointed out, if we try to protect too much, it'll fail.
So the LP address, this doesn't necessarily have to be page aligned. Okay. You just have to make sure that the size parameter doesn't end up spilling over into too much memory. So you have to be kind of careful about what you choose there. So as long as you make LP address, make sure your shellcode is above whatever you make the address for LP address, you should be fine. As long as the size isn't too much, too.
And as long as it doesn't cross a page boundary.
Yeah, exactly.
Which theoretically it shouldn't for any of this that we've been doing thus far, but just in general.
So for the first step, you should just try to get like OXCC shellcode to execute. This is small and you can fit it in anywhere. And afterwards, you can work with screwing around and trying to get actual like room for your calc.exe shellcode. Okay, well, I'll throw out some more hints. I'm obviously not going to give it all away. Well, it's not like a trick I can give away. It's just like brutal refinement process. but I'll try to point you guys in the right direction some more. So for those of you working on your own, you might want to avert your eyes and ears for a few minutes. Okay, so we've already talked about how we would get the absolute address of virtual protect. Can I get the board on the screen? Thank you. So, okay, so we got the absolute address of virtual protect. We all know how to do that. We know how to get the address of ESP into a register. Let's see, what else do we need to do, guys? We need to write some of that stuff forward on the stack, right? Into our stack frame. So, let's assume that we just executed this. So I'm going to come a little bit more to the left, Bill. All right, so we got some basic ROP code for getting the absolute address of virtual protect. We got some ROP code for getting the address of ESI into a register, basically. Now, let's see. What sort of gadgets do you recommend we use for writing stuff into our stack frame? Okay, so at this point, with this last gadget we did, we are going to do we did the add ESP to like a zeroed out region. PSI, I'll make sure I got the order right. Let's see, what was I proposing that we do here? This was a move EBX, so I assume with this one I was doing like move ECX EBX minus 7.4. So at this point, if we come down here, we can assume that ECX equals approximately ESP. I'm saying approximately because since we're doing return-oriented programming and returning all the time, ESP is, what we wrote to ESP back then is a little bit less than where we're at now, since we've been copying a bunch of stuff off the stack. Okay? But approximately ESP, we can always add or subtract some offsets to try to get to where we want to go. So what we want to do now is try to write some stuff forward in our stack frame. So, okay, look at this. ECX is approximately ESP. Now, we couldn't immediately just use gadgets 10 through 12 because, like I said before, our value of ESP is a little bit less than what it should be since we've been hitting all those recurrent statements. So we probably need to increase the value of ECX, right? Some amount. And how are we going to add an arbitrary value to ECX? 7. So let's assume, I'm not going to go through all that stuff that we did before, of like writing a constant value somewhere and then trying to read it back. Okay, so let's assume that previously in our ROP payload, we have stashed away a constant into that a memory address we can get to with gadget number 6. Okay? You guys should all be convinced we can do that at this point since we kind of already talked about how you would accomplish that, right? So let's assume we've already in our payload stashed away some constant we want to add to ECX so we can get ESP pointing at our stack frame. All right? Everyone looking there? Then we would do pop EBX, right? Okay. And now we would need to do let's see, where am I? Oops, but we can't just do move ECX that constant, can we? Because it would clobber our value of the stack pointer. Oh, but I guess we could just do the add one, right? Add ECX. Yeah. So I'll say pop EBX, and this is, data 3 plus 3FCC3D00. All right. Just as that neutralizes out that 3FCC business. Okay. So at this point, PBX there, add, that would add a constant value onto ECX. So we did at this point add ECX, PBX minus 3F, blah, blah, blah. Right here we would have ECX equals ESP plus data. So let's assume we've calculated this constant intelligently, such that ESP, whatever it was back when we wrote it there, plus data 3 equals the address of our stack frame, our fake stack frame on the stack with incomplete information. Now, what should we do? We've got ECX pointing at our virtual protect stack frame. What we're still missing in the stack frame is the return address, the LP address, the address of virtual protect. I guess the first thing we should just go down the list. What's the first thing we need to write is the address of virtual protect, right? So back here, with this gadget, we figure out how to actually get at the address, derive the address of virtual protect, but notice just in the ECX register. So we would have to have stashed away this value, this calculated value, okay? And so how would we have done that? Let's look at, if we wanted to stash these away, we could have first made a copy of the value with move EAX ECX. And we could have popped the value into ECX with gadget number 2, a flash data address. Then we could have written the derived virtual protect address using gadget number 5. So that's how we could have stashed away that calculated derived value of virtual protect. And now we want to write it to ECX, because ECX is pointing at our stack frame. So what we need to do is, looks like gadgets 5, 10, 11, and 12 sort of write a value to our stack frame at ECX, and we have to get EAX equal to the value we want to write there. So how are we going to do that? You know, because we can't hard code the address of virtual protect on the stack because we don't know what it is. So 6 is right now pointing at the stack frame pointer, which we calculated, so we would clobber it. So I guess we can do, let's see, 8. Maybe make a copy of the address of the stack frame. Anyone have any ideas? Notice some gadgets that are like kind of interestingly missing from this list of ROP gadgets we can use, and they're pushes. It'd be nice if we could push and then pop back into a register, but why can't we do that? So because ESP is pointing at a ROP payload, so if we push anything on the stack, we would just clobber our ROP payload. So we can't do that. So basically, if you think about it at a higher level, what we need to have happen is we need to get EAX equal to virtual protect address we need to get ECX equals stack frame that we're filling out. So how are we going to do that, guys? Gino on steroids, that's how you think of it. So I guess we can easily get the value of ECX as the address of our stack frame if we were to calculate it via this kind of thing and then write it back to the stack, to another stack data area. Then if we popped 0, or no, we really don't have to do that. If we did gadget 6, we can easily get the address of the stack frame back into ECX at will. So that's not so bad. But how do we get the address of virtual protect then into EAX? Well, we would have to write the address of virtual protect somewhere and get it into ECX by using 6. Then we have to copy it with 8 and then change ECX to be the address of the stack frame using 6 again. Then we could use gadget 5 to write the address of virtual protect into the stack frame. We all excited about doing that? Oh yeah. Debugging this is good fun to do. I don't expect everyone to obviously make their own ROP payload and get this working, and it's quite difficult. I just want you guys to sort of understand that it is possible to defeat ASLR in this way, okay, and how you would generally do it, and kind of understand the nitty-gritty details of how you actually pull off ROP programming. It sounds easy in theory, but in the entire Flash, OCX file, these are kind of the best gadgets they could come up with. So, you have to get really creative with how you accomplish things. And make sure you do things in the right order, and make sure you don't clobber over a register that's storing a value that you really want. So it definitely takes some trials and tribulations to get this all right.
The nastiest part is when you finally start building your stack frame for the call, because you've got some value of ESP that you figured out at some point, and then you've got to figure out what to add to that to hit where ESP is now.
So what I would do, if I were the person that had come up with all this work, is I would let the ROP payload run, see where it was writing those values to, because you know you can write the values sequentially with the ECX plus 4, ECX plus 8, etc. Calculate where those are in my payload, and then just fill in the constants around that in my payload. That way I didn't have to know kind of like a priori calculate how this is going to all end up. I can just like, okay, well with this ROP code, I know I'm writing the address of virtual protect, my return address, and the LP address sequentially at this in my payload, so I'll just fill in the rest with hard-coded values. If everything else after the first 3 parts of the stack frame, virtual protect, return, or I get an LP address, I can hard-code the rest. Even old protect I can hard-code if I just put in a flash 6 data area. People don't seem excited about ROP programming anymore.
It's all good until I get to that part where you actually construct.
Yeah, it's always easy in theory. I mean, theoretically, what that guy showed in like the return-oriented programming paper is with a very limited set of gadgets, probably just a few more than this, you can build like a Turing complete program that can do anything. So you can accomplish it. It just takes like a lot of nastier constraint solving to get everything in the right order. Also, you have to make sure you have enough room in between your return-oriented programming payload and the fake stack frame to pull everything off. Because your return-oriented programming payload is going to end up being pretty big. As you can see, doing these simple operations takes quite a few instructions. And so you have to make sure you give yourself enough room in between the ROP payload and the fake stack frame.
Can't assume infinity.
No. It probably helps if you make your stack pivot lower. So some of you guys use the 868 stack pivot, which gives you less room in between where you end up and like the exception handler you're overriding. So that's like the maximum limit of where you can go. So you should maybe use like the 600 stack pivot and give yourself more room for your raw payload. I think you can pull it off with the 868 one, but it'd be cutting it pretty close. But you can always just find like a sub ESP return on ROP gadget, and that would like effectively jump backwards in your payload. My suggestion would be just to try to build some small ROP payloads and just step through them and make sure, okay, well, I know using this small payload I can get the value of virtual protect into the registered EAX. And try a different small ROP payload, like, okay, I know with this one I can write the value of ESP and add a constant to it and write it back to this address in flash memory. And then once you have all your like mini ROP programs working, figure out how to stitch them together to get it to all work. I hope at this point everyone realizes that we're able to chain all of these gadgets together because we control ESP, right? Should be obvious to everyone. Just want to reiterate how important it was for us to do that stack pivot the very moment we gain control of EIP. So we also control the stack pointer because that allows us to do all this. So here's another simple question. Should all these gadget addresses appear before or after your fake stack frame in your payload file? Before.
Fake stack frame is at the very end of your ROP kit.
Yep. Exactly. So these should be lower on the stack and executing, and then they'll write those things ahead on the stack at higher addresses on the stack. And if anyone has gotten the calculator to spawn with the debt bypass and thinks Rob programming sucks and wants to leave, you're totally allowed to, because this is optional material. Okay, you're not going to need any of this stuff for tomorrow. But since you guys were interested in it, that's what I'm talking about. So you're welcome to leave if you need the stuff, just as long as you got the calculator to spawn with the debt bypass. That was the most important part. So I'll go ahead and say that you guys are free to go. Not really got to cover new material today, any more new material today. For those of you that feel ambitious about this, please try to work through it for the rest of today or tonight or whatever, and we can maybe spend a little bit of time talking about it tomorrow if anyone manages to get it figured out. And if you want to work on it later, that blog post is a really good guide, so you're welcome to try to follow along with that. But so you're free to go, but I will stay around here for anyone that wants help with it.